In this lesson we will go through what you get in the RoboSlam development kit. The largest item there is a breadboard. The breadboard allows us to construct circuits without soldering. Inside the breadboards are metal clips that hold any component legs that are poked through the holes. These clips connect component legs together in different ways. So you can build a circuit on the breadboard without doing any soldering, any wire wrapping. You just plug components in. Connections or clips between the red and blue stripes run vertically like this. They're typically used for distributing power across the breadboard. Connections in the middle run horizontally as shown here. They're typically used for putting components in. The valley in the middle has no connections under it. That allows us to place chips on the breadboard without shorting all their legs together. So components in column E do not connect to components on column F, unless of course you want to and you put a wire in. The microcontroller provided in the kit is a Texas Instruments MSP430G2553. It's a little chip with a lot of power. It's got everything in it to make a complete computer. It's got memory for storing programs that doesn't get lost when you switch the power off. It's got RAM for data, I/O ports to control external devices, and timers to measure time intervals and to generate output waveforms. We programmed the MSP430 chip using the Launchpad circuit board. You typically buy this with the chip in a kit from TI, which costs about €10 or $10. The Launchpad kit provides an interface between your computer and the MSP430 in the breadboard. It allows you to download programs and debug programs. We're going to bring 3 wires from the Launchpad to the breadboard with the MSP430 processor, and we can program it that way, and we can even debug it if we want to. Now, the MSP430 microcontroller chip isn't powerful enough to drive motors. It's optimized for doing calculations and executing instructions and programs, but it does not drive large currents. Now, in order to do this, we're going to need what's called a driver chip. This driver chip that we're using is the 754410, and it's got 4 outputs on it that can drive motors forwards and backwards, and there's plenty of power in it to drive the motors we use in our kit. The MSP430 will interface to this chip, which in turn will interface to the motors and drives them back and forth. Speaking of motors, there's 2 motor modules. Each of them is a yellow box. There's a gearbox in there, and you can see in the picture here the little pink rotor sticking out. That's got a notch on it, or it's kind of rectangular shaped, and you'll see why in a moment. But in behind that there's a gearbox to reduce the motor speed but increase its torque. So it makes the robot easier to control because it's not whizzing all around the place out of control, and it also provides it with plenty of strength to push other opponents out of the way. The wheels, as you can see in this picture, have a matching hole that goes onto the motor shaft and allows the motor drive the wheel without any fear of it spinning on the shaft. This is a picture shows how they get assembled together. Now, the kit also comes with an ultrasonic sensor. The sensor allows the robot to find other robots or other objects, much in the same way as a bat does. An ultrasonic pulse is sent out. It bounces off an object in its path and returns back to the sensor. The sensor then outputs a signal indicating how far away the target is. And our MSP430, the brains of the whole operation, can use this information to figure out how far away a target is and to chase it. So the further the target is away from the sensor, the longer it takes for the signal to get back. Now, if it's very far away, you won't get any signal back. It has a limited range, but over the distances we're talking about, maybe a meter or so, it's quite reliable. Now, the lights or indicators we use in this circuit are LEDs, light emitting diodes. These have a right way of going in and a wrong way of going in. there's two terminals on them, a cathode and an anode. Current leaves the cathode and enters on the anode. How do you know which way around it is? Well, there's a couple of ways. If you haven't cut the wires yet on the LED, the shorter one is usually the cathode. If you have trimmed them, hold it up to the light and look through it. And on the image here on the left hand side, you can see that one of the electrodes is it's shaped like a backwards 7, I suppose, and it's much bigger than the electrode on the right. So the one on the left here is the cathode. The expression people use is a fat cat because it's a fatter electrode. If you can't see that, if it's very frosted, the LED, you might also notice that the body of the LED is not completely round, that there is an area down around here which is flattened to indicate the cathode side. Now, resistors are used in various places in the circuit. Their job is to limit the current flow to safe levels. Resistance is measured in ohms. The bigger the resistance, the more ohms it has. You can tell how many ohms your resistor has by reading the color codes. You can see these color bands here on the resistor. The colors are listed, have the following meanings: black 0, brown 1, 2, red 2, orange 3, yellow 4, green 5, blue 6, purple 7, grey 8, and white 9. So if you want to figure out the value of a resistor, you look at the one here, say on this screen, we have A, B, and C. Those three colors indicate the value. So we say we have A, B plus C zeros. Now A is brown, so it's 1. B is red, so it's 2, and C is 3, so we have 3 zeros. So the resistance here is 1, 2, and 3 zeros, or 12,000 ohms. Its tolerance is 5%. That means it can be a little bit above and a little bit below 12,000 ohms by as much as 5%, but typically they're more or less spot on. Now, there's two resistors in the kit. There's one, it's a 270 ohm resistor. We're using those for limiting the current in the LEDs. Now the color codes here are, it's red, purple, brown, so it's 2, 7, and 1, 0, so it's 270. And there is a 2.2k resistor, which is red, and orange, which is used to control the reset on the circuit. Now, capacitors are used to store charge. They're placed in near circuit components that require short bursts of current, such as motor drives and so on. They can be topped up over a longer period by the power supply or battery that's supplying them, so that they can then provide these little short bursts of current. Now without them, you'd put a lot of stress on the power supply, and maybe you can upset components nearby when you draw big pulses of current. For example, let's say you want to suddenly switch direction on the motors. That involves a big swing of power, which could cause the voltage to fluctuate a lot on the breadboard, which might cause problems for your chip, for your MSP430, making it crash. So if we put capacitors in around the place, they're able to supply that short-term burst of current and keep the voltage stable. Now, just to be sure that we're all okay with breadboards, let's have a little go at lighting up an LED. Here's a circuit showing a battery, a resistor, and an LED. Now you have all of these components in your circuit, in your kit. We expect current now to flow from the battery through the resistor and to light the LED. So this is a schematic view of our circuit. If we switch to the layout view with the breadboard, you can see it's like this. So you put the 4 batteries in, you connect 0 volts, or the negative terminal of this battery, to the blue track here, and the positive voltage, which in this case here is going to be 6 volts, because you get 4 1.5 volt batteries in series. We're going to connect that up here along the red rail. So to get the LED to light, we take a wire from the red rail, bring it down to the top of the resistor, over here, into the LED, it lights up, and current exits here and comes back onto the blue strip here, back to the battery. So current flows in a loop. If you assemble this, you should see the LED light up.